So what we've decided to do for our project is that we wanted to make a system in which friends and family who we weren't able to make an electronic key for, because our keys at our apartment are the electronic locks that require a magnetic key, and so we cannot make copies of those, and we only get one key per resident. So we set out to find a way in which we could allow friends and family, or guests in general, access to our home or apartment whenever we were not there, or able to physically let them in, or say our roommates weren't there. So what we did is basically a mountable mechanism that will mount right over the deadbolt slide on your door, and at that point all the person has to do is walk up. They will connect to a website that you have set up on a computer in your home, say your desktop or a laptop that you leave running, or there's an option to even get a dedicated piece that will connect to your router that can host the server. And then all you do is you connect to that website, you log in with your account that has been set up by the owner of the home, and then that will permit you access to unlock the door or re-engage the lock on the door, depending on the command you enter in on the web interface. From there, as an administrator or as the owner of the home, it's easy to keep track of the accounts and the keys that you've issued. There are basically one type of key, and it is a key in which expires after 2 days. Should that person need extended time into your home after 2 days, you have the option to re-extend the key for another 24 hours. It's a very simple process managed through the web server, as seen here. And then you can also see the status of the accounts and also all of the users that have made an account through your web portal. And it is also easy to administrate that as well. From here, the actual mechanism is comprised of a motor, a 9-volt battery, a 5-volt power supply, and the control mechanism. In this case, our Tiva C-Series microcontroller. The Tiva will receive a command via its Wi-Fi module, and then will issue the appropriate voltages on pin 0 and pin 1 that will then go through more or less a tri-state device in order to bump up the voltage a little bit from 3.3 volt signal to a 5 volt signal. And from there it is fed into an H-bridge, which will basically control the motor itself. So the H-bridge is a special microchip that receives one input in for each way it's going to go. So in this case, since it's a simple stationary motor, it only goes one direction depending on the polarity, and then it goes in reverse if you reverse the polarity. So the H-bridge will only need to be used on one half of the chip itself as opposed to all 4 pieces. From there, it will receive the 5 volt signal in through the H-bridge, and it will output a 9 volt signal to the motor. And a basic truth table can be followed of, whenever it is inactive, it's receiving 2 low signals as its input from the Tiva controller, which causes the motor to do nothing. When it is unlocking, it will receive 1 signal high, and the other signal will be low. When it is locking, it will then invert that signal to where the original high signal now is low and the original low signal now is high. And then that will cause the motor to go in the reverse direction as when you unlocked it. So very, very simple circuit involving only 2 microchips and a standard 5 volt power supply and a 9 volt power supply. In this case, you could you could take the 9 volt power supply on a separate, small circuit, put it through a step down circuit more or less, and receive all of your voltage from one simple 9 volt battery, and only involve no other power sources other than the 9 volt battery.